Hello everyone, today I want to talk about Kirchoffs Voltage law. So let's say we have a resistor, right? And we know that's positive and negative, and there's 20 volts here and 10 volts here. Logically, that means that it's decreasing because it's flowing like this. And if you're like, wait, how are voltages like here? Basically, how can I explain? Like, yeah, usually like we have 1 voltage for one resistor, like when we work out on circuits. However, you have to understand resistors, they they resist energy, so there will be either way energy here, and it will go past here, so it will decrease either way. It's just the voltage here, like that we use to calculate, is kind of like the middle point, I guess you can say that. So basically, this is the negative way. However, there's batteries, and batteries do something very different. So let's say there's 0 volts here and 12 volts here. Batteries, they are able to not upscale, but like basically transfer the energy here, like yeah, basically upscale the voltage. So like the current, which is basically like to the voltage, so that means the voltage is up, it increases. Over here the current goes like this, gets less. So yeah, so you understand better. Basically, let's say we have a resistor here, right? And current goes like this. Will it be like, will the voltage be positive or negative? Basically, look, remember resistors, they take energy, like the current, because like again they're pressure in it and all that, so they take away energy, so it's going to be negative. Even if it goes like this, most likely, yeah, I'm pretty sure. But wait, I mean, it can have AC. Basically, yeah, even like this, it will stay. It has to go through this whole thingamajiggy, so it will most likely take energy from right. I'm not sure about that, I'll be honest. Let's say we have a battery, right? No, that's too big. A battery, positive, negative, and let's just quickly draw another battery. So positive, negative, and over here the current is going like this. Over here the current also going like this. So which one do you think will have positive and negative voltage? Positive, yeah. Which one will have the positive, which will have the negative? So look, over here the current is going from the positive side, over here from the negative. Well, you have to remember that I'll just quickly draw the stuff. So if current goes from positive to negative, that is negative voltage. That's current, by the way. I think I said if current goes from negative to positive, that's positive voltage. So this one is negative, this one is positive. So here we have an example, right? And we have to write an expression that highlights Kirchoffs voltage law. This is the short version. Shows some voltages around the circuit must add up to 0. So like the voltages must add up to 0. Add up. So okay, let's just quickly do the thingy majiggies. And then straight away what we need to do, we have to find out what's the current, because we're not given it. Because we need the current to work out voltages, like for the R1s. So basically all these added up, 30 divided by 12, because that equals R. Okay, good one. Okay, 12, 30. Okay, maybe not, I guess. Thanks. So the current is 0.4. So after we found that the current is the same everywhere, because this is series circuit. So series, the current is everywhere. We already should know this. So, and let's calculate what is the voltage for this area. For this area, so because this is positive, this is negative, we know that the positive is bigger than the negative. So over here, let's just put it straight away. Over here, 0 volts, 0. I think it's better to do it in green. Then over here it should be 12 because that's the start. Now we should calculate what's voltage over here. How we calculate voltage is, remember Ohm's law, IR. We have the I, we have the R. So we're able just to do yeah, let's just do it. 0.4 times 8 equals, that's not a plus, I'm sorry, that's a times 8. Aha, yes. So the voltage here is 3.2. 12 minus, to calculate what, so let's say this is B, this is A, B, C. D we don't really care about because it's 0, we know that. So to calculate what's different, like what's B, we have to do 12 minus what's the voltage for R1, which is 3.2. It's going to decrease, by the way. Like, I mean, that's logical because like we're already like, you know, doing the minus and stuff. However, because like of the resistor is going to decrease, you have to understand that. And then sort of this is going to be 8.8. Now here, what do we do? We do, so 4, because 4 times 10, 0.4 times 10. And then, so over here will be 4.8, because 88 negative 4 equals 4.4. And then just do, so you check that as 0.4 times 12. Okay, why is my laptop lagging? 8.8 is decreasing. These two give us 0. So that's that answer. Okay, here's another question. Example. So let's just plot the fiddly pigs. Okay. This time let's just do an equation so we change 100% understand what's going on. So look, this time we have 2 batteries. Let's call this one B battery 1, battery 2, and we know that this is the R1 or blah blah blah. So the current goes like this. So this one, B1 is positive. So like the voltage for it, and then it goes like this. So negative R, like V1, which is basically R1, but like because we're doing the voltage ones, then we could just put it as V1. Take away, then over here, remember, it's not about exactly the direction of the current, it's about the negative to positive. Negative to positive it gives positive, because like even over here, guys, it's logical. So and it's 8, so we're not going to put numbers right now. Take away again is take away because of the resistor, V2, and all of this equals to 0. So let's plot the numbers in now. So positive 12 and take away, oh no, I'm sorry, plus 8V, take away 50, well, I, we can just put it as I because we're going to do the current later, because voltage equals resistance times I, so we can just put that. Take away 30I. So let's just work out the current straight away so we don't get lost or anything. So the current is, add these two, 30, 80, and then add these two, 20, so that will be this, like this. Okay, of course it doesn't want to work. Let's go. 80. So the current is 0.25 amps. So now we're able to work out the number. These 20 voltage, positive ones, take away, for example, we don't really need to calculate it right now, but yeah, let's just put 80i equals 0 for now, but like we don't need that. Then let's move it here so we have more space. So let's just put this as A, B, C, D, because this time, why not? Just this over here, 12 logical, no arguments. Over here, 0 logical, no arguments. So current going like this. So what will be the voltage here? So we need to work out what's the voltage here. We know the current is the same because this is in series. So that will be 0.25 times 50, because that's how you work out voltage, remember? So over here is 12.5. 12 take away 12.5 equals negative 0.0. So negative 0.5. Then over here goes here, so it's a positive. Remember, it's a positive. So this gives 0.5 because 0.5 plus 8 equals this. That's a thingy-majiggy, what's it called? A dot. And then just to check that this does equal to 0, to check the Kirchoffs law, 30 times 0.25, 7.5, 7.5. These two take away, give 0. Hip hip hooray, everything is working. Okay, so, volts. So here's our last example question. Let's put the thingy-majiggies, and guess what, this time, it's not 4 thingy-majiggies, it's 5. The reason for that is that these nodes, that I think they're called nodes, they show the change in voltage, like in general, like that's where the change is. And usually the changes are over here because like they go out, like it goes here, so there is a change. And because there's another battery here, there is a change here, so there's a node here, blah blah blah. Okay, now I would like to say that this does look a bit scary maybe because there's literally 3 batteries. However, calm down, because look, so this over here, it goes positive, right? However, over here it goes also, like on its side it's also going positive, but they go against each other. Just like here, this one also goes here because of like direction. Also, another thing is that with batteries, like in questions, the one that's smaller is the negative, the one that's bigger is the positive. However, yep, back to the business. However, because these are even collided, 30 volts is smaller than 50, that means the current will go this way because it's winning. So yeah, that's how it, if it went this way, that's not a problem also, because you just do it like this and you just do the opposite basically. So let's go, let's work out the current first of all. So 100 ohms, these 2 resistors added, and then we divide it by the batteries, and that will be 80 divided by 100 equals 0. So 50, 100. I messed up by saying 80. I must stop it right now.
So we have 50 minus 20 minus 20V is equal to, example, we have a current of 0.2.
Oops, sorry guys, basically I messed up fully. Okay, remember, literally, so this goes like this goes like this, which means it's a negative. These 2 are negatives, this is a positive because it goes positive. So yep, Don't forget about that. So which means 50 take away 30, so 20 over 100 equals to 0.2. So the current is 0.2 amps. And let's go with the maths. So we have to calculate the voltage here. That would be 0.2 times 30. You know the drill. 6. 6, and then 1 second. I'm just checking stuff out. Okay, yep. And then so 50 take away 6 equals 44. And then here you take away 20, 24. Over here you take away 10, 14. Over here, let's just quickly check that. Oh, what if it's not 14, which it will definitely be. 0.270. Wow. Kirchoffs law actually works. And my voice is broken, thanks. Okay, and that's all of it.